All right, here we go. Number 1 on the study guide. Which choice shows a true conditional? Make sure, look, it's got to be a true conditional, first of all. Okay? With hypothesis and conclusion identified correctly. So you have to have a true conditional statement, first of all. All right, so answer choice A. Today is Saturday if yesterday was Friday. Today is Saturday if yesterday was Friday. So what follows the if is the hypothesis. There's your hypothesis. Okay? The rest of the statement is your conclusion. So here's your conclusion. Now let's determine if this is true. All right? Today is Saturday if yesterday was Friday. That's true, isn't it? Okay? Hypothesis. Yesterday was Friday. That is correct. Conclusion. Today is Saturday. That is correct. So it looks like answer A is the correct choice here. Just make sure that Monday when you take your quiz, you're going to have to read through all of these, okay? Read through all of them. Make sure that, first of all, the statement is correct and that they get the correct hypothesis and conclusion. Hypothesis is after the if. Conclusion is after the then. But in this case, there is no then. But by process of elimination, this is after the if. So it's the hypothesis. Whatever's left is the conclusion. Got it? All right, good. Let's look at number 2. Number 2 is a pattern problem. Based on the pattern, what are your next 2 terms of the sequence? They're all going up, aren't they? All the terms in the sequence are going up. So you ask yourself, how much are they going up by? Are they being added to or are they being multiplied by? And it looks like from 9 to 16 is a 7. And from 16 to 23 is another plus 7. So they're adding 7 each time, right? So let's take 30 plus 7 would be 37. And then 37 plus 7 would be 44. So there's the next 2 terms in your sequence. And problem number 2 on the short answer. Based on the pattern, what are the next 2 terms of the sequence? Alright, what's the pattern with the numerator? Okay, this first 2, this 2 is just like 2 over 1, isn't it? Okay? The numerator is staying the same. Agreed? Alright. So the next 2 terms are going to have a 2 in the numerator and a 2 in the numerator. Those are going to stay the same. Now, there's a pattern to the denominator. They're increasing, aren't they? But they're not increasing by the same amount. If they're not increasing by the same amount, take the second denominator, which is 5, divide it by the first denominator, which is 1. And what does 5 divided by 1 equal? Good, it equals 5. So that means, and then what you want to do is you want to check it on the third denominator and the second denominator. Take the 25 and divide it by 5. And you get a 5 again, don't you? That means they're multiplying each denominator by 5 to get the next denominator. Okay? So 625 times 5, 3125. Leave that number in your calculator. And then times 5 again, 15,625. So those are your next 2 terms in the sequence. And while we're here, what conjecture can you make about the 13th figure in the pattern? The 13th figure in the pattern. So I like to number these. 1, 2, 3, and then we got 4, 5, 6. Alright, and we're looking for the 13th. So we got trapezoid, horizontal rectangle, vertical rectangle, right? Yes. Yeah, there's a couple different ways to look at this problem. You could look at it in groups of 3, or you can look at it in groups of 6. Okay? Because every 3 has the same pattern. This pattern, the first 3, has the same pattern as the second 3. Agreed? So this shape right here, this vertical rectangle, will be the 3rd, it'll be the 6th, it'll be the 9th, won't it? And won't it also be the 12th? Okay, so this moves us to the 12th figure. Well, what comes right after the vertical rectangle? The trapezoid. All right, so we got the trapezoid. All right, number 4. What conjecture can you make about the 15th term in the sequence? So if we number these terms, we got 1st, 2nd, 3rd, 4th, 5th. We want the 15th. All right, so we're going AB, AC, AB, AC, right? So what's the next couple terms going to be? An A and then a what? A B. Because we're going AB and then we're going AC. So every other letter is an A. And then in between there, all the odd letters are A's, aren't they? See it? 1's an A, 3's an A, 5's an A, 7's an A, 9 is an A. So is 15 odd or even? 15's odd, isn't it? So what are all the odds? A's. So what's the 15th term going to be? An A. Okay. So instead of writing them all out, once you determine the pattern, you know, because what if they ask for the 49th term in the sequence? All right. 49th term, what's it going to be? 49's odd. So it's going to be an A, because all the odd numbered terms in the sequence are an A. You don't want to have to sit down and write A, B, A, C, A, B, A, C, A, B, A, C, and number them all. Just find the pattern. Okay, number 5. What is a counterexample for the conjecture? Remember that a counterexample is an example of something being incorrect. Any number that is divisible by 4 is also divisible by 8. Okay? Any number that is divisible by 4 is also divisible by 8. So if you list the numbers that are divisible by 4, all right, if we say divisible by 4, 4 goes into 4, it goes into 8, it goes into 12, it goes into 16 and 20 and 24. Those are all the numbers that are divisible by 4. Okay? It's 4 times 1, 4 times 2, 4 times 3, and so on. Any number that is divisible by 4 is also divisible by 8. Well, 12 is divisible by 4, isn't it? But is it divisible by 8? 8 does not go into 12. There's your counterexample. Counterexample, the number 12. Okay? The number 20 is another counterexample. All right? 20 shows that that statement is false. All right, number 6. What is the conclusion? Conclusion of the following conditional. The conclusion is what follows the then. So, highlighter. I'm going to highlight the hypothesis. The hypothesis follows the if. So here's what follows the if. That is the hypothesis. The conclusion follows the then. But in this case, there isn't a then. When there's not a then, the rest of the statement is the conclusion. So there it is. All right, there's your conclusion. Number 7, ask you to identify the hypothesis and the conclusion of this conditional statement. Hypothesis follows the if. So after the if, today is Wednesday. There's your hypothesis. Conclusion follows the then. Tomorrow is Thursday. There's your conclusion. And now, it might seem like it's more work right now to highlight the hypothesis and the conclusion, but when you take your quiz is going to be multiple choice, and you're going to have to read through the answers, okay? Using colors when you're reading through the answers will be helpful. The other thing that will be helpful when you're doing a multiple choice and you have to read multiple options is to scratch out the ones that aren't correct, okay? As soon as you see a hypothesis labeled incorrectly, scratch the whole answer out. Alright, it'll be much less confusing. In number 8, identify, same thing, hypothesis and conclusion. So here, your hypothesis we're going to put in yellow. What follows the if is the hypothesis. So here's your hypothesis. Lost my highlighter, it looks like. Alright, that's your hypothesis, and what follows the then is the conclusion. So right here is what follows the then, that's your conclusion. All right, number 9, draw a Venn diagram to illustrate this conditional. This was in your notes yesterday or the day before. Here's a Venn diagram for a conditional statement. Big circle is the Q. Little circle is the P. Hypothesis goes in the small circle. Conclusion goes in the big circle. Alright, the P represents the hypothesis, the Q represents the conclusion. So your Venn diagram, no matter what this description is, cars are motor vehicles. This is not in if-then form, so we got to put it in if-then form. Alright, so we can say something like, if a vehicle is a car, then it is a motor vehicle. We're not worried about the truth value of this statement, we're just worried about the Venn diagram. So the car is the hypothesis, so your Venn diagram would look like this. In the small circle goes the car. Alright? Motor vehicle is the conclusion, so the motor vehicle goes in the big circle. Yes? Well, then you need to slide your seat if you can, because I can't do anything with the projector. There's another seat over here behind Kalia if you want to move over there. Okay, number 10. What is the converse of the following conditional? Converse from your notes yesterday. Converse is when you switch the hypothesis and the conclusion. Alright, so in this statement, in this statement, what follows the if is the hypothesis. So a point in the first quadrant is the hypothesis. The conclusion is what follows the then. Its coordinates are positive. Alright? So you have to write a statement now, and you have to switch the hypothesis and the conclusion. So we're going to say that if a point's coordinates are positive, then it is in the first quadrant. Alright, when you're writing the converse of a statement, you're going to switch the hypothesis and the conclusion. Number 11, same question. What is the converse of the following conditional? So identify your hypothesis and conclusion. The hypothesis follows the if. A number is a natural number. There's your hypothesis. And your conclusion is what follows the then. So here's your conclusion. So the converse of this statement is going to be if a number is a whole number, then it is a natural number. Alright, number 12 here. Another name for an if-then statement is a... Here's the answer, guys. They basically answered the question with the next sentence. Okay? Another name for an if-then statement is a conditional. Every conditional has two parts. The parts following the if is the hypothesis, and the part following the then is the conclusion. Alright, 13 and 14. Write this statement as a conditional in if-then form. All triangles have three sides. We got to put it in if-then form. So we can say if a figure is a triangle, then it has three sides. And it doesn't have to be exactly those words. If a figure is a triangle, it could be if a shape is a triangle, if a polygon is a triangle. Okay? Any of those will work. And number 14 here. All triangles have three sides. Huh. Yeah, it's the same question, isn't it? That won't be the same question on your quiz tomorrow, okay?
Are you sure?
Or your quiz on Monday. Yeah, I'll fix that. Okay? Any questions on any of that study guide? Alright. If you need this outside of class, again, I will upload it to YouTube.